trying to understand the universe. It's at least set things in motion such that at some point civilization understands the universe far better than we do today.
The James Webb Space Telescope has uncovered something that could completely rewrite how we think planets are formed. In a mysterious region of space known as NGC 1333, astronomers discovered something unexpected: 6 massive planets drifting freely, with no stars, no orbits, and no rules. But what Webb saw next might reveal a hidden pattern in the universe, one we were never meant to find. Roughly 960 light-years from Earth, NGC 1333 is a dark, cloud-covered region of the sky. It is considered a stellar nursery, a place where stars are supposed to be born. But buried deep in its dark clouds, something was moving that defied expectations. One day, Webb's powerful lens captured something strange. Instead of spotting newborn stars surrounded by glowing clouds, scientists found 6 colossal objects, planet-sized, but alone. These weren't just any planets. They were giants, each between 5 and 15 times more massive than Jupiter. Cold, silent, and drifting through space. And most shocking of all, they weren't orbiting anything. They simply floated like cosmic castaways. According to what we've been taught, planets form around stars. First, a star is born from a collapsing cloud of dust and gas. Then, leftover material forms a spinning disk around it, where bits stick together to become planets. That's how Earth, Jupiter, and Mars came to be. But these 6 giants didn't follow the script. They weren't anywhere near a star. In fact, some were so large that they bordered on being small stars themselves. Scientists refer to such odd objects as brown dwarfs, a term for failed stars. They're too massive to be ordinary planets, but not quite massive enough to ignite nuclear fusion and shine like real stars. They just sit in space, dim, cold, and in between. Even so, that still didn't explain everything, because one of those 6 ghostly giants had something wrapped around it. A disk, a swirling ring of dust and gas, exactly the kind of structure that forms moons and smaller planets. Just like the early days of our own solar system, when Earth's moon formed from a similar disk. Now here's the twist. If this ghost giant had been thrown out of a star system, kicked out like an unwanted guest, it shouldn't still have that disk. The violent ejection would have torn it away. And yet, the disk was intact, calm, orbiting peacefully. This changed everything. It meant the ghost giant didn't form like a planet at all. It formed like a star. Ray Jayawardena, a space scientist from Johns Hopkins University, put it clearly: nature has 2 ways of making these kinds of objects. Some are born like stars, from a collapsing gas cloud. Others form like planets, from dust sticking together inside a spinning disk around a star. But here's where it gets even stranger. Webb should have spotted smaller objects, too. Its instruments are sensitive enough to detect bodies even smaller than 5 Jupiter masses. Yet it found none. Not a single one. This was just as important as the discovery itself. Because in that corner of the universe, it seems that small objects don't form through star-like collapse. There's a boundary, a cosmic cutoff. Below a certain size, the universe switches to a different formation recipe. It's like baking cookies and only getting the giant ones from the oven, no small ones at all. You'd start to wonder, is it even possible to bake smaller cookies at this temperature? That's exactly what astronomers are asking now. Why didn't Webb find anything smaller floating out there? Maybe, just maybe, there's an unspoken rule, a size limit for objects that are allowed to form like stars. Below that, the universe plays by different rules. And while we don't yet know exactly where that cutoff is, 6 massive, solitary objects, some with dusty halos, others drifting freely through space, have sparked new questions about our universe. But these mysterious giants are only part of the bigger picture. Astronomers are now focusing their attention on other regions of the sky, searching for more ghost planets, possibly even smaller than these, in places like the Orion Nebula, an area teeming with stars and cosmic dust. These elusive objects might not emit light, but they are far from lifeless. One of them, the lightest ever observed with a disk of its own, could be forming tiny moons or even smaller planetary bodies. It's like a miniature solar system without a sun. Imagine that. A lonely planet in the darkness, quietly creating a family of moons around itself, a floating world, crafting companions in silence. And just when scientists thought the discovery of these 6 giants was enough to shake up the cosmic rulebook, something even more surprising emerged. When early astronomers began studying the night sky using real instruments, the cosmos seemed simple. Bright, burning objects were stars. Smaller, colder bodies orbiting those stars were planets. Easy, right? But space doesn't conform to our categories. Brown dwarfs, often described as failed stars, blur the lines. They emit a faint glow in their youth, not from nuclear fusion like real stars, but simply from the heat of gravitational compression. As time passes, they cool and fade, some becoming as dark as coal. Yet many are still massive, several times heavier than Jupiter. The 6 rogue giants spotted in the NGC 1333 star-forming region sit right in that ambiguous zone, too large to be planets, too small to ignite as stars. But what shocked scientists wasn't just their size. It was their solitude. Every planet we know of, from Mercury to Neptune, orbits a star. That's part of what defines a planet. But these 6 objects aren't orbiting anything. They're drifters, wanderers. The term scientists use is rogue planets. Cosmic orphans, born from stardust but raised in darkness, far from the warmth of any sun. Some rogue planets might have been ejected from their systems. Picture a young solar system crowded with newborn planets. One gets too close to a massive neighbor, or maybe 2 worlds collide in a gravitational tug-of-war, and one is flung out, banished from its orbit into the endless void. But that's likely not what happened here. One of the rogue objects still has a dusty disk wrapped around it, a crucial clue. If this planet had been thrown out of a solar system, the violent force would have stripped away anything fragile, including that disk. It would have been torn apart. But this one, the disk remains, spinning like an extreme version of Saturn's rings. That means this object was never kicked out, it was born this way, born free. Scientists now believe it came into existence like a star, when a massive cloud of gas collapsed under its own gravity. But unlike a true star, the cloud didn't have enough mass to ignite nuclear fusion. Instead, it formed a brown dwarf, a quiet, smoldering object with no fire, just fading heat. This might sound subtle, but it's actually a major shift in how we understand planets and stars. Until now, we separated the two. Planets form in disks around stars. Stars form from collapsing gas clouds. Period. But the James Webb Space Telescope is rewriting that script. Webb is powerful enough to detect objects smaller than 5 times the mass of Jupiter. Think of it as a flashlight strong enough to spot dust bunnies under your bed. And when scientists used it in NGC 1333, they saw nothing smaller than 5 Jupiter masses. Not a single object. This tells us something critical. When nature forms things through the star-making method by collapsing a gas cloud, there may be a lower limit. Anything smaller than 5 Jupiter masses might be too light to form that way. Instead, those smaller objects may only form the planet way in disks orbiting stars. In other words, there might be 2 different cosmic recipes. One for stars, one for planets. And you can't mix ingredients. You can't use the star recipe to bake something smaller than 5 Jupiter masses. If that's true, it solves a mystery that has puzzled scientists for decades. What is the smallest possible object that can form like a star? Astronomer Ray Jayawardena, one of the scientists leading this discovery, has pursued this question for nearly 20 years. He's been hunting for the boundary line, the smallest mass that can still be born like a star. This new finding is a big clue, but even Ray isn't ready to close the case just yet. He knows NGC 1333 is just one cluster, one corner of the universe. He wants to explore other regions, especially denser areas like the Orion Nebula, where star formation is even more chaotic. Interestingly, in Orion, scientists have already found objects smaller than 5 Jupiter masses. That raises another possibility. Maybe those tiny bodies formed as regular planets and were later ejected. If true, then the density of a star cluster could influence what kind of ghosts it creates. Still, what's been found in NGC 1333 is the clearest evidence yet. The lightest object with a disk, a faint halo spinning around something just barely heavy enough to be called a star. And that disk is important. Disks like these are cosmic nurseries. They're where planets and even moons are born. Earth's moon likely formed from a debris disk around early Earth. Jupiter's massive moons came from the swirling disk that surrounded it billions of years ago. So what if this rogue object, the smallest of the six, has moons forming around it? What if it's building its own tiny solar system in the shadows? That would be like finding a campfire in the middle of a desert. No house, no town, just glowing embers in the dark. And the only reason we saw any of this, a wild machine floating 1,000,000 miles from home, long before it discovered ghost planets wandering through deep space, before it captured ancient galaxies glowing from the edge of time, before it became the sharpest eye humanity ever aimed at the cosmos. The James Webb Space Telescope was just a dream. Back in the late 1980s, before Hubble even launched, some visionary scientists were already imagining something greater. Hubble was incredible, but it viewed the universe through visible light, just like our eyes. To glimpse the oldest, most hidden structures in the universe, the first stars, the first galaxies, we needed something colder, more powerful. Something that could see the invisible glow of heat, infrared light. And now, that dream is reshaping everything we thought we knew about how planets, stars, and maybe even entire solar systems are born. That light is ancient, stretched and softened by billions of years of cosmic expansion. To catch it, we needed a telescope unlike anything the world had ever seen. And so, a dream was born. In the beginning, it was just ideas, sketches on paper, big hopes captured on thin sheets. They called it the Next Generation Space Telescope, a project so ambitious it didn't even have a complete design. Just a vision. A giant gold mirror, a sunshield the size of a house, and no backup plan. By the mid-1990s, the dream started becoming real. NASA teamed up with the European and Canadian space agencies to turn those sketches into blueprints. But building this machine wasn't easy. Every component had to fold to fit inside a rocket. It had to survive freezing cold temperatures and operate 1,000,000 miles from Earth, with no chance of repair. Then came the delays, the cost overruns, and the engineering nightmares. Years passed. Tests failed. Budgets ballooned from billions to more billions. But the scientists didn't quit. They refined. They upgraded. They rebuilt. In 2002, the telescope finally got its name, not just any name, but that of James E. Webb, the former NASA chief who guided the agency during the Apollo era. A man who believed that science was just as important as landing humans on the moon. A man who championed bold ideas. The telescope would carry his name and his spirit. After more than 20 years of building, adjusting, and waiting, the day finally arrived. December 25, 2021. Christmas morning. The James Webb Space Telescope launched from South America aboard a rocket named Ariane 5. The world held its breath and it soared. Stage by stage, it unfolded like a cosmic flower. The sunshield opened. The mirror clicked into place. Every step, hundreds of them, worked perfectly. Weeks later, it reached its destination. A place called L2, 1,000,000 miles from Earth. Far enough that the warmth of our planet wouldn't interfere. There, in the silence of deep space, it settled into a temperature of around -370 degrees Fahrenheit and waited. Then it opened its eyes. In July 2022, the world got its first glimpse of what Webb could do, and everything changed. Galaxies stacked behind galaxies. Glowing rings of gas. Newborn stars cocooned in clouds of dust. And these were just the test shots. Webb wasn't just taking pretty pictures. It was rewriting the story of the cosmos. With a mirror spanning over 21 feet, composed of 18 gold-coated hexagons, Webb became the largest telescope ever deployed in space. Each segment moves with surgical precision to sharpen the view. But why gold? Because gold reflects infrared light incredibly well, and that's what Webb was built to see. Its mirror collects the faint heat signatures from stars, galaxies, and planets, signals too weak for the human eye, and feeds them into instruments that decode their stories. That's how we found the ghost planets. That's how we saw galaxies born just a few 100 million years after the Big Bang. That's how we're looking into the past. This power came at a price, a big one. Originally estimated to cost between $1 and $3 billion, the project's budget swelled over time. By the time Webb launched, the total had reached nearly $10 billion. Most of it went into building and testing, nearly another billion into operations. Still, most scientists agree it's worth every penny, because Webb is not just a telescope. It's a time machine, a chemistry lab, a planet hunter, and a black hole observer, all rolled into one. And it's just getting started. Since its launch, Webb has been on a discovery spree. It captured a planet in its death spiral, slowly falling into its star, a cosmic goodbye in slow motion. It imaged baby stars forming inside the pillars of creation, those famous towers of gas and dust. It witnessed rings of gas around dying stars, rippling like smoke from a long-extinguished candle. It even observed a supermassive black hole devouring matter, spinning it into heat and light before it vanished forever. New data arrives each week. Every month, another chapter in space's story is rewritten, and scientists are racing to keep up, because some of what Webb is revealing simply shouldn't exist. Like enormous galaxies in the early universe, far too massive, far too soon. Like chemical fingerprints on alien worlds, possibly hints of life or something else. Webb isn't just showing us the universe. It's transforming how we understand it. The telescope was built to last at least 10 years, maybe longer if the fuel holds out. And NASA is already preparing for what comes next. The Nancy Grace Roman Space Telescope, set to launch in a few years, will scan wide areas of the sky, helping Webb zoom in on the most promising targets. Together, they'll track dark matter, hunt rogue planets, and dig deeper into the fabric of cosmic history. But for now, Webb leads the way, floating alone in space, watching everything. The gold mirror, the silent eye, the ghost catcher. When those 6 rogue worlds appeared in Webb's lens, it wasn't luck. It was the result of decades of dreaming, building, failing, fixing, and refusing to give up. Webb is more than just a machine. It's a promise that humanity will keep asking questions, keep looking deeper, and keep reaching further. That even in the coldest, darkest corners of the cosmos, something might be watching back. Here's the big question: what if the James Webb Telescope isn't just looking at space? What if something is looking back through it? Let us know what you think in the comments. Don't forget to like, subscribe, and share this video if you love space stories.